Hey guys, Mr. Bowman here. Today's learning objective is in what? And we are learning to calculate the area of given sectors. So hopefully you're all good with my voice. I've got a bit of a cold and a sore throat, but we're getting through our videos anyway. So just to recap, we have been looking to do with the trigonometry of circles the last couple lessons. So last time around we looked how to find the arc length. This lesson we're going to find, well, how do you find the area of that entire sector? Area of sector. So we'll be looking to find that shaded area. And in the next lesson, we're actually going to be chopping the top off, so to speak, and how to find out the area of a segment. So that's what we're focusing on. And today's one, area of a sector, as I just said. And the formula we need to be aware of is the area is always going to be equal to 1/2 times r squared times radians, or times the angle. So hopefully that makes sense. What I'm going to do is I'm going to change pen colors. Let's just get straight into some examples so we can see how it works. So question 1. So I've got a circle sector. The internal angle in radians is pi over 3, and that has a radius of 9. We'll call that 9 millimeters. What would the area of that entire shape be? So in our case, the area, that's always equal to 1/2. So just writing down the formula here, r squared times the angle. So that's going to be 1/2 times 9 squared times pi over 3. And when we simplify all that a bit more, that's 1/2 times 81 times pi over 3. And we can put that into our graphics calculator, and we're going to get 42.4 millimeters squared. And I've rounded that to 1 decimal place. So that was the first question. And what we did there is we found the area of a sector. So area of a sector, and we were given radians for that one there. So that's what we did there. So let's change pen colors. Let's have a look at a different type of question, how this could come up. So question 2, we've got another segment. So let's say it's a bit smaller this time around. And let's say that internal angle is pi divided by 10. And it's got a radius of 12 centimeters. So similar steps, we start off with by writing down the area formula. So the area is equal to 1/2 of r squared times the angle. And don't forget that angle, it must be in radians. So we should actually note that down before. So must be in radians. Okay, so that's going to be 1/2 times 12 squared times pi over 10. So that's going to be 1/2 times 144 times pi over 10. And when you do that, so you got pi divided by 10 times 144 times 0.5. That gets us to 22.6 centimeters squared. And I've rounded that to 1 decimal point again. So hopefully that makes sense. And again, we did a similar thing. We were looking at the area of a sector, and we were given radians for that. So we're going to do one more question, area of a segment. We'll do it in slightly different context. This time we're going to be given degrees. So question 3 down the bottom. So let's say that there is 100 degrees. It has a radius of 11 meters. What would the area be? So the first step we need to do is we need to convert the degrees into radians. So it's going to be 100 times pi over 180. And just a reminder, the pi represents radians, so it goes on the top. The 180 represents degrees, so it stays down the bottom. And when we do that, that becomes 100 pi over 180. And we can simplify that again, 10 pi over 18 which is 5 pi over 9. So 5 pi over 9. Now that we've got the degrees, we can actually go ahead and use our formula. So the area is always going to be equal to 1/2 of r squared times the angle. So it's 1/2. Oh, I've written pi in there, but that's not meant to be there. So 1/2 times 11 squared times 5 pi over 9. When you put that in a calculator, 5 pi divided by 9 times 121 times 0.5. That gets us to 105.6 meters squared. That was 1 dp. And what we just did there is we calculated the area of a sector. And in this case there, we were given degrees. So we had that extra step of converting it to radians. So hopefully you found these first 3 questions relatively straightforward. They're the bread and butter. They're the easy questions for this skill. What we're going to do is I'm going to pause the video and we're going to go through a couple other questions to do with finding the radius and the angle if we were given an area instead. So pausing the video and make sure you've got these down. Okay guys, we're back. We're now going to look at our 4th question, and this is the type of question where we're actually going to try and work backwards to find the radius of our segment or our sector. So let's draw this one here. So let's say our angle here, that's a right angle, which is pi divided by 4. So I'm dealing with radians. We don't know the radius, but we do know the whole thing. It has an area of 24.2 meters squared. So how would we go about finding this? Similar to the previous stuff, we write down our formula. So the area is equal to 1/2 of r squared times pi. We substitute in everything we know. So we know that the area is 24.2. That's equal to 1/2 of r squared times pi over 4. And from here, we've got one variable r. We go ahead and we use our algebra skills to solve that. So what I'm going to do is I am going to simplify this side here. So it's 24.2. That's going to be equal to pi r squared divided by 8. So we're going to move the divide by 8 over as it times 8. So 24.2 times 8. We're then going to move the times pi over as divide by pi. That there is equal to r squared. So r will be equal to the square root of 24.2 times 8 divided by pi. And we are going to get 2 answers for this. So 24.2 times 8 divided by pi. That gets us to 61.6. We're going to square root that number. That gets us to plus or minus 7.85. And from here, we're just going to make a little note. We're just going to ignore negative 7.85 because that's our radius. We can't have a negative radius because we're dealing with measurements. And that means our R value, 7.85 meters. And that there was rounded to 2 decimal places. So that was one. The working was a bit more, that algebra was a bit more intense. But hopefully you've got a good understanding of how you can work backwards to find the radius if you've been given the area of that sector. So same deal, I'm going to pause the video, I'm going to get rid of our working. If you haven't got this example down, please make sure you do. So we're now up to question 5, and this is where we're trying to work backwards to find a given angle. So this time around, so we've got a small sector. We don't know the angle sitting inside. We do know that the radius is 7.1 meters long, and we do know the area. We do know that's going to be equal to 31.1 meters squared. So similar approach to the previous question. We've been given the area, we've been given the radius. We can substitute those in and then rearrange and solve for the angle. So let's give that a go. So start off with our formula. Area is equal to 1/2 of r squared times the angle. So 31.1, that's going to be equal to 1/2 times 7.1 squared times the angle. And we've left that as the angle symbol because that's what we don't know. That's what we're trying to solve for. So that there is a 1/2. So times 1/2, which is the same as divide by 2. If we move that to the other side, that's going to be times 2. So 31.1 times 2, that's going to be equal to 7.1 squared times the angle. 7.1 squared is multiplication. Let's move it to the other side as division. So it's going to be 31.1 times 2 divided by 7.1 squared. And that there will be equal to the angle of our shape. So the angle will be equal to, let's plug this into our calculator. So we've got 31.1 times 2. That's going to be divided by 7.1 squared. And that gets us to 1.2339. And that was rounded to 40p. That's currently in radians. If we wanted to convert it to degrees, so let's go through and do that. So the angle would be equal to that number times 180 divided by pi. Let's see what that comes to, times 180 divided by pi. And that gets us to 70.7 degrees, and that there was rounded to 1 decimal point. Okay, so that was that. Again, same deal. If you haven't got this example down, please do. And the last type of question we're going to use, just one, how do we use these skills to solve weirder little problems? Okay, and the last question we're going to look at, how can we do these for problem solving? And I've got a weirder scenario for us to look at. So let's say we've got a sector. And then let's say if we extend that a little bit, I've got a bigger sector sitting around it. How would we go about finding that curved area? So noting that's not a segment from before, because that has to be a straight line through there. But what this is actually going to be, this is going to be two sectors. So let's say the area is going to be equal to the big sector minus the small sector. So we'll have to go ahead and calculate those individually. So let's say we've been told, well, that there is actually going to be 30 degrees. And let's say the big radius, so big radius, I'll call that BR, that's going to be equal to 12 centimeters. And the small radius, SR, that's going to be equal to 8 centimeters. So we need to go ahead and find the area for both of those. So the big sector, we're going to start off with our formulas. That's going to be r squared times pi, and then the same again for the other ones. The only thing is we will be just changing the r value. So it's going to be 1/2 times 12 squared times, in this case around, we need our degrees in radians. So let's convert that. So 30 times pi over 180, that's going to be equal to 30 pi over 180, which is going to be equal to pi over 6. Pi over 6. We're then going to have to subtract the same, but with the smaller radius, 8 squared times pi over 6. And when you put that into your calculator, we'll try to get numbers for both of them. So we've got pi divided by 6 times 144 times 0.5. That gets us to 37.7. We're then going to subtract the area of the smaller sector. So we've got pi divided by 6 times 64 times 0.5. That's 16.8. And 37.7 minus 16.8, that gets us to 20.9 centimeters squared, and that was rounded to 1 decimal place. So we can use these skills to solve weirder extended problems. So video was on the longer side today, but hopefully you found it useful. And we've got 6 different variations of questions. Before you finish, make sure you get all the examples down so you know how everything works. Once you've done that, let's get into heaps of practice.